Imagine you're on a commercial flight, cruising at 35,000 feet. You look out the window at the clouds, feeling like you're high above the world. Now, imagine that plane never lands. It keeps flying up out of the atmosphere, past the moon, and toward the nearest star. To circle just one of the largest stars we've ever found, that same airplane would have to fly at full speed for over 900 years just to complete a single lap. You would be born, live your entire life, and have 10 generations of descendants all before you finished circling a single object in our sky. We like to think of space as a big, empty room, but it is actually a gallery of monsters so large they defy the very laws of physics we wrote to describe them. And today, we're going to find the biggest of them all.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
It's easy to feel like this is useless information. After all, the size of a galaxy cluster doesn't help you pay your rent or fix a broken car. But there is a psychological shift that happens when you truly grasp the scale of the cosmos. We live our lives in a human-sized world. We measure things in minutes, miles, and dollars. But the universe doesn't care about our metrics. Understanding these giants is the ultimate cure for small-mindedness. It forces your brain to stretch, to rewire itself to see the big picture. When you realize that our entire history, every war, every love story, and every invention has taken place on a rock that is effectively invisible on the cosmic scale, your daily anxieties start to lose their grip. You aren't just a person in a city. You are a conscious witness to a structural masterpiece. To understand that masterpiece, we have to start with the things that glow. For a long time, we thought our sun was big. You could fit 1.3 million Earths inside it. But in the grand scheme, our sun is a yellow dwarf, a pebble. If we look toward the constellation Scutum, we find Stephenson 2:18. If you replaced our sun with this star, its outer edge wouldn't just swallow the Earth. It would extend past the orbit of Saturn. It is roughly 2,150 times wider than the sun. But here's the problem. Stars aren't supposed to get this big. According to our models of stellar evolution, a star this massive should be so unstable that it blows itself apart. Yet, there it sits, a bloated, red titan. It represents the absolute limit of what matter can do before it collapses under its own weight. It is a giant made of fire, but even this star is a flea compared to the things that eat light. As big as a star can get, there is a drain in the universe that can swallow billions of them at once. We used to think black holes were rare. Now we know they are the anchors of almost every galaxy. But ton 618 is something different. It's what we call an ultramassive black hole. It has the mass of 66 billion suns. To visualize that, imagine taking every single star in the Milky Way galaxy, grinding them up, and feeding them into a single point. You'd still need to do that several times over to reach the mass of ton 618. Its event horizon, the border of the hole, is 242 billion miles wide. It is surrounded by a disk of gas swirling at nearly the speed of light, heated to millions of degrees. This quasar shines with the brilliance of 140 trillion suns. It is so bright that it outshines its entire host galaxy by thousands of times. It is a cosmic engine of pure destruction, a place where space and time simply stop existing. But ton 618 is just one point in space. What happens when these monsters start to group together? If you could see the gravity of the universe, our neighborhood would look like a giant funnel. For decades, Astronomers noticed that the Milky Way and all our neighboring galaxies were being pulled toward a specific patch of sky at 1.3 million miles per hour. The problem? We couldn't see what was pulling us. It was hidden behind the zone of avoidance, a thick curtain of gas and dust from our own galaxy's center. When we finally used X-ray and radio telescopes to peek behind the curtain, we found the Great Attractor. It isn't a single object, but a massive gravitational, equivalent to tens of thousands of galaxies. It's like a giant magnet pulling on a handful of iron filings. Everything in our local corner of the universe is sliding toward this point. But the Great Attractor isn't the boss. It's just a small part of a heavenly structure that makes us look like dust. In 2014, scientists mapped out the motion of over 8,000 galaxies and discovered that we are part of something called the Laniakea supercluster. The name means immeasurable heaven. Imagine a map of the universe where galaxies are like drops of water. In Laniakea, those drops follow paths like rivers, all flowing toward a common center. This structure is 520 million light-years across. If you look at a map of Laniakea, the Milky Way is just a tiny, glowing thread on the very edge of one of its branches. It's the first time we realize that our home isn't just a planet or a galaxy, but a massive, interconnected web of light. Yet, even this immeasurable heaven is dwarfed by a wall that shouldn't exist according to the rules of time. The universe is 13.8 billion years old. Because light takes time to travel and matter takes time to clump together, there is a speed limit on how big a structure can grow. Then we found the Hercules Corona Borealis Great Wall. It is a filament of galaxies that is 10 billion light-years long. That is roughly 1/9 of the entire observable universe. If you were traveling at the speed of light, it would take you 10 billion years just to get from one end to the other. This discovery sent shockwaves through the scientific community. According to our current understanding of the Big Bang, there hasn't been enough time in the history of the universe for gravity to pull that much matter together into one structure. It's as if you walked into a forest that was only 10 years old and found a tree that was a mile high. It suggests that there is something fundamentally wrong or missing from our standard model of the universe. If this is the stuff of the universe, what about the terrifying nothingness in between? Most of space is empty, but the Bow-Tess void takes empty to a terrifying level. It's a sphere of nothingness approximately 330 million light-years in diameter. To put that in perspective, if the Milky Way were in the center of this void, we wouldn't have discovered another galaxy until the 1960s. We would have looked out into the night sky and seen nothing. Total, absolute blackness. Astronomers call it the Great Void. There are a few lonely galaxies inside it, but far fewer than there should be. Some scientists have joked, perhaps half seriously, that the void looks like it's being cleared out by a Type 3 civilization, or that it's a bubble in the fabric of spacetime itself. It is a reminder that the largest things in the universe aren't always made of matter sometimes. The largest thing is the absence of it. What is holding these walls and voids together? To see the true giant, we have to look at the ghost of the universe. If you could zoom out until the entire observable universe was the size of a handheld ball, you wouldn't see galaxies. You would see a web. This is the cosmic web, the largest pattern in nature. It is made of invisible dark matter that acts as a scaffold. This web is what dictates where galaxies are born and where they die. The filaments of this web are hundreds of millions of light-years long, and the knots where the threads meet are where the largest clusters of galaxies live. This is the ultimate discovery. It shows that the universe isn't a collection of random objects. It is a single, organized structure. It looks strikingly like the neural network of a human brain or the growth of a slime mold. It is the skeletal system of reality. But there is a cold spot in this web that might not belong to our universe at all. Near the constellation Eridanus, there is a cold spot in the radiation left over from the Big Bang. It is a massive area that is significantly colder than its surroundings. One of the most mind-bending theories is that this cold spot is a collision point. Some physicists believe our universe is just one bubble in a multiverse, and this cold spot is the place where another universe literally bumped into ours, leaving a cosmic bruise. If this is true, then the biggest thing we've ever discovered isn't a wall or a web. It's the realization that our entire 93 billion light-year universe is just a single atom in an infinite, bubbling sea of other worlds. We've spent this time talking about things that are billions of light-years wide. It makes us feel like dust. But here is the twist. Size does not equal complexity. A black hole is huge, but it is simple. It has mass, spin, and a charge. That's it. A galaxy is just a collection of gas and gravity. But you, the person watching this, are a biological machine capable of contemplating the Hercules Corona Borealis Great Wall. There are more possible connections in your brain than there are atoms in the observable universe. You are a giant of complexity. We are the only part of this massive, 10 billion light-year structure that has developed eyes to see itself and brains to measure its own shadow. The universe is big, but you are the thing that gives it a name. When you look up at the stars tonight, remember that you aren't just looking at distant lights. You are looking at the intersections of a cosmic web that stretches beyond the limits of human imagination. You are a part of that web, but as massive as the universe is, it's also changing. It's expanding, and it's doing so faster and faster every second. What happens when the universe grows so large that the cosmic web finally snaps? Watch our video on the Big Rip to find out why the very giants we talked about today might one day be torn apart by the vacuum of space itself. If you enjoyed this journey to the edge of the void, subscribe to MindSpark. We're building a community of the most curious minds on Earth. See you in the next one.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,